Hello and welcome back to another video. Today we are continuing with our machine learning series, and now we are going to look at how to properly test our model using cross-validation. This is really important because in the last video we trained the model to fit our data, but if we only test it on the same data we trained it on, and that does not really tell us how good the model is. So let's get right into it. First, we import numpy and pyplot like before, and then we also import random. After that, we load in the car data and shuffle it. Car data equals np.loadText brackets, then in speech marks, car data.txt. numpy.random.shuffle car data. So we shuffle the data so that it is put into a random order. This is important when we split the data up into groups as we do not want any bias. Next, we decide how many chunks we want to split the data into. Chunks equals 5, car data chunks equals numpy.array underscore split car underscore data chunks. Here, this command is splitting the data into 5 chunks. This means we are doing a 5-fold cross-validation. Each chunk will take a turn being the test data, while the rest of the data is used for training. We always want to have more training data, so in this example, 80% of all of our data will be training and only 20% will be testing. This is why this is used in machine learning more than, say, statistics, for example, because we should have so much data in machine learning that even 20% of the data is still a lot. After that, we create an empty list called losses. This is where we will store the loss from each fold, and then at the end, we average them together to see the overall performance of the model. Now we loop through each chunk for I in range chunks. Inside this loop, one chunk becomes the test set. dtest equals car data chunks I. Then everything that is not in that chunk becomes the training set. dtrain equals numpy.array, and then inside we're going to have a for loop. for x in car data if not x in dtest. What this does is it loops x for every amount in the car data, and it will add it as long as x isn't already in dtest. So every time the loop runs, we train on most of the data and test on the small part we left out. This is the main idea behind cross-validation. Next, we split both the training data and the test data into our inputs and outputs. Now this is going to look very similar from last video. So first, let's split it up. X-test equals d-test square brackets colon 0. Y-test equals d-test square brackets colon 1. X-train equals d-train, same, and Y-train equals d-train, and the same as previous. So the engine size is still our input, and the fuel efficiency is still the value you want to predict. So yes, now this is really going to be from the previous video. If it doesn't make any sense, then go watch the previous video. So next we build the vandermonde matrix for the training data. X underscore vandermonde equals numpy.vander bracket xtrain 4. This means we are fitting a polynomial of degree 3 because we're using 4 columns in the matrix. Then, like before, we solve the normal equations to get the best coefficient for the model. A equals x vandermonde transpose times x vandermonde, and B equals x vandermonde transpose at y train. Theta star then equals numpy dot Lionel G dot solve AB. Perfect. Now that the model has been trained, we test it on the test data. So first we build the vandermonde matrix for the test inputs. X underscore test underscore vandermonde equals numpy.vander x test 4. Then we apply the coefficients to get the predicted values. Predict matrix equals theta star times x test vandermonde. then giving the y-test predictions by summing them all together. Y-test prediction equals numpy.sum I for I in predict matrix. So now we have predicted fuel efficiency values for the test set. Next, we visualize the result. We plot the test data, the training data, and also the predicted test data. So plot.scatter x-test, y-test label with test statistics and s equals 20. Plot.scatter x-train, y-train, label that with train statistics, s equals 7. And plot.scatter x-test, y-test prediction, then label it again with predicted test statistics with s equals 20. With the labels and title and legend we add at the bottom here. And then display the graph. This lets us clearly see how close the predictions are to the real test value. After that, we calculate a loss for this fold. Losses.append numpy.mean y-test prediction minus y-test squared. This is called the mean squared error. So this is the mean squared error for that chunk, so it tells us how far away the predictions are from the actual values. Once the loop has finished, we average all of those losses together. Cross-validation loss equals numpy.mean losses. And then after that, we just print the cross-validation loss. This gives us the overall cross-validation loss for the model. Now, when we run the program, the data is first shuffled and split into 5 chunks. Then, for each chunk, the model trains on the rest of the data and tests on the chunk that was left out. We then get a graph showing the training points, the test points, and the predicted test points. If the predictions are close to the real test data, then the model is performing well. At the very end, we print the average loss across all 5 folds, and this gives us a better idea of how the model is working on unseen data. Perfect, and that is all there is to it. This is how to use cross-validation to properly test your machine learning model. If you found this video helpful, please like the video and subscribe to the channel, as it really helps support the channel. Thank you for watching, and I hope to see you in the next one.